Welcome to this explainer. Today, we're diving into an absolutely massive leap in conversational AI. For the longest time, our interactions with computers have been, well, pretty heavily restricted. But we are officially moving away from those rigid, clunky systems toward a completely fluid, genuinely human-like interaction. We're going to demystify what's known as full-duplex architecture, and we'll see exactly how it's fundamentally changing the way machines listen and speak to us. But before we get into the heavy tech, I want you to think about your own daily habits for a second. Why do we talk to computers like robots? Try to recall that frustrating, rigid, one-way street of older voice assistants. You probably know exactly what I mean, right? You lean in, you speak a very short, carefully worded command, and then you just wait. It's an incredibly unnatural way to communicate. We basically strip away all of our human nuance just to make sure the machine understands a simple request.
And that brings us to the real hero of our explainer, full-duplex architecture. Put simply, this is a technology that allows a system to listen to your voice and speak to you at the exact same time. It's a literal game changer. Instead of operating like a walkie-talkie where only one person can broadcast at a time, this technology perfectly mirrors a natural human dinner party conversation. People can interject, they can talk over one another, and seamlessly yield the floor.
Okay, let's take a quick look at our roadmap for today. We'll start with the end of the walkie-talkie era, then we'll peek inside the seamless loop and walk through the 5-step change. After that, we'll check out some real-world superpowers before finally wrapping up with the risks and limits.
All right, let's jump right into Section 1, the end of the walkie-talkie era and the shift from one-way to continuous talk.
So older half-duplex systems are your classic one-way street. They're totally defined by long silences, push-to-talk buttons, and a complete inability to handle any overlapping sound. It's literally like communicating with a walkie-talkie from the 1990s. But full-duplex, that offers the fluid, continuous reality of a two-way interaction. It handles our natural interruptions without skipping a single beat, creating a truly continuous flow of communication. And here's where it gets really cool. Full-duplex even allows the AI to interject with natural listening cues without actually interrupting your train of thought. This is a concept called back-channeling. Imagine you're telling a long story to a friend. They naturally drop in an uh-huh or an okay, just so you know they're following along, right? Well, a full-duplex system can do exactly that. It's processing your speech and providing active listening feedback at the exact same time.
Moving right along to Section 2, inside the seamless loop and how the machine thinks and speaks simultaneously. 200 milliseconds. That ultra-low number is basically the holy grail of voice AI. You see, if a system takes longer than that to respond to an interruption, our brains immediately recognize it as a machine, and boom, the illusion of a natural conversation is completely broken. Hitting this specific target latency is what allows the system to perfectly match the timing of human speech.
Now, what's really wild is how these three components work in parallel so the system doesn't have to wait for a pause to process your voice. Instead of waiting around for a completed audio file, the system uses a listening window, which basically samples your voice in tiny 160 to 240 millisecond chunks. At the exact same time, it uses parallel prediction to actually guess the next sound you're going to make, which completely combats any internet lag. And all of this relies on high-speed network infrastructure, like WebSockets, to constantly stream data in both directions.
To pull all of this off, the system uses a decoupled architecture. And honestly, this is the secret sauce. It completely separates the act of speaking from the heavy, deep thinking happening in the background. The voice layer manages the direct interaction, maintaining emotion and speech flow. Meanwhile, the reasoning layer is sweating furiously in the background to search the web or solve a complex problem for you. So the AI can literally keep humming or acknowledging you on the voice layer while its brain is out fetching data on the reasoning layer.
To make that split actually work, the AI uses an acoustic perception technique called semantic end-of-turn detection. This is absolutely vital. I mean, how does the machine know if your brief silence means you're completely done with your request or if you're just pausing to think of a word? Older systems just measured the silence, but this new model practically mind reads. It uses the actual meaning of the words you just spoke to deduce if your thought is logically complete.
Now that we know the parts, let's hit Section 3, the 5-step change, and step through the decision-making progression.
We are talking about a split-second journey here. First, raw stream ingestion constantly drinks in your audio data. Next, semantic analysis instantly decides if you're just making an ambient background sound or actually speaking a word. Then, state evaluation rapidly panics and checks, wait, should I stop talking? Should I keep going? Step 4 is task delegation, shoving the really hard questions to that background reasoning layer we talked about. But Step 5? Step 5 is the magic. Output alteration. The system instantly drops its current speech cue and completely alters its vocal path if you interrupt it. It literally updates its memory bank right there on the fly.
So what happens when we unleash this? Let's look at Section 4, Real-World Superpowers and the Practical Upgrades to Daily Tasks.
The most profound upgrade here is actually a behavioral change in us. This is so fascinating because the AI adapts to our pacing without losing its tone or emotion. It drastically alters our psychology. We completely ditch those stunted robotic commands. Instead, we begin interacting using long, complex, organic sentences, fully confident that the AI is going to catch all the nuance and follow along just like a human collaborator would.
This completely transforms voice assistants into true digital collaborators across so many industries. In customer support, for example, you can now make mid-sentence corrections, like, oh, actually fixing an address, and the AI will instantly adjust without making you start the entire menu over. It enables live language translation, where two people can talk over the phone naturally without those awful, awkward pauses. It's also incredibly powerful as an accessibility tool, allowing individuals with speech impediments the patient, thinking pauses they actually need. And of course, it unlocks true hands-free productivity, letting you navigate complex software while you're driving without ever having to glance at a screen.
But before we get too carried away, let's move to our final section, the risks and limits. Let's ground this with the technical hurdles and security risks. There are definitely still severe hurdles to this architecture. First, there's modality interference. This is where mixing acoustic and text data can actually cause an AI to sound beautifully natural, but confidently lie to you about a fact. Not great. Next up is hypersensitivity. The system can easily mistake a background cough or a quiet "okay" as a command to stop talking, which totally breaks the conversational flow. You also have tool call latency, which causes sudden, awkward silences when the system is frantically fetching data. And finally, running all of this requires massive server power, which means high costs and major jitter if your internet connection happens to drop. Furthermore, because it's generating audio live and instantly, we're facing a brand new frontier of safety challenges. Think about it. When AI just generated text, engineers could put filters in place to scan a paragraph for inappropriate content before showing it to you. But when an AI generates audio on the fly, it entirely bypasses those traditional safety filters. It makes it significantly harder to catch and block verbal slips or malicious outputs before they are actually spoken aloud.
Now, if you're curious to see the actual underlying code and network infrastructure of this decoupled architecture, I highly recommend searching for the OpenAI GPT Live Architecture Breakdown explainer to dive deep into the technical weeds of exactly how these low-latency voice layers decouple conversation from the background reasoning models. It's an absolutely fascinating resource.
So, I want to leave you with this final, provocative thought. When computers learn to talk seamlessly like us, how will it change what we say? As the friction of technology disappears, the boundary between human conversation and digital interaction is going to blur entirely. Thank you so much for joining me to demystify full-duplex architecture.